On CP2-3, we're going to explore the relationship between a radius and a tangent line, and we'll explore the relationship between two tangent segments from outside of a circle to the edges of a circle. So when we're thinking about a radius and a tangent line, if I've got my tangent here, I've got my radius here, if they are meeting at one point, we're calling that point the point of tangency. Okay, so when we use that phrase, that is what we are talking about. And we're going to look at a quick GeoGebra, and we're first going to think about what is the measure of each pink angle. So I'm going to slide in my tangent, or two tangents rather, and I can see they're filling in that pink angle, and then they're able to fold it over and it fits perfectly. Okay, and I can look at either side. I really just need one. So as I'm thinking about that, okay, well, if they're the same, and if they're forming a linear pair, then they must each be 90 degrees. So I can fill that in. Because a linear pair equals 180, and congruent angles. So each is 90. And then apparently in this update of the GeoGebra we're using, they didn't mark the letters, but we're going to look at the lengths from the point outside to the circle. So from that line, and then we swing it over here, and those will be the same. So they are also congruent. So a tangent to a circle is always going to be perpendicular to the radius drawn to the point of tangency. It'll always meet at a 90-degree angle. A radius and a tangent, it's always a 90-degree angle, even if it's not marked as 90 degrees. The segments outside of circle, so on this one we're just talking about, here's my circle. If I have a radius here and I have a tangent here, this is 90 degrees. On this next one, we're going to have two tangents. So we're going to have a circle, two tangent segments from a point outside the same circle. So the same point to the same circle. And this one's a little bit harder to draw, so bear with me. There we go, that wasn't too bad. Those are congruent, the segments are. So tangents from the same point to the same circle, this much and this much, have to be congruent. So we're going to practice doing some problems with that. When I'm looking at this one, I'm trying to solve for x. I see that this is a tangent and this is a tangent, and that I have radius here. I know that these will be 90 degrees, and then I know, hey, this is a kite, because my radiuses are the same, my tangents are the same. I know a kite adds up to 360 degrees. I've taken care of 180 with these two. So I've got 180 left, subtract off the 140 degrees, and x must be 40. Over here, I don't have a radius, and sometimes kids are tempted to like, oh, let's just draw them in. And you could do that, but we still don't know what this is, and we don't know what this part is. So that's not as helpful as it might seem initially. What I do know is that these two tangent segments will be congruent. So I have an isosceles triangle right here. I've used 55 degrees for my vertex. This angle and this angle must be congruent. So I can do 180 minus 55, and I get 125 left for my two angles. 125 cut in half, each angle measure x must be 62.5 degrees. When I get to something like this, I'm going to use a little bit of everything that I've learned, okay? And there's some other methods to go through this and other things you could solve first. The biggest thing and my biggest tip for these is keep filling things in even if you think you don't need it. You're right, you might not need it, but you could also be wrong and you might need it to find something else. So I'm going to fill in 86 here because that's my central angle, and 174 here because that's a central angle. And then I know this one will be 90. I'm going to go ahead and fill this angle in by subtracting from 360. So if I add the 6 over to the 174, that's at 180. So I have 180 left minus 80. I have 100 here. I just subtracted from 360 going all the way around. Then I know this is an isosceles triangle. If I've used 100 degrees, there's 80 left for my two base angles. So each one gets 40. The 40 and this angle make a linear pair, so this must be 140. And now I can say, hey, guess what? This is a quadrilateral. I don't know what kind of quadrilateral, but I do know that every quadrilateral adds up to 360. So I can do 360 minus my 140, and I'm at 220, minus the 90 degrees that we found, and I'm at 130, minus 80 will put me at 50, minus 6 more puts me at 44 for x. All right, we're gonna skip this one for now. This one, though, is one that you will see frequently on your checkpoint. Okay, and sometimes it's tempting for kids to say, oh, x and y have to be the same, v and 5. But that's not what we learned today. What we learned today is that these two parts are the same, and these two parts are the same, and these two parts are the same. Okay, so I know right away that y and 4 will be congruent, so I can fill 4 in for y. If y is 4 and the whole side is 7, then x must be 3. X and v have to be the same, so I can put 3 in over here. And then w plus 2 has to be the same as 5. So w must equal 3. And then the whole side z has to be the 4 plus the 5.